In this section, we're going to be talking about difference of squares. Now, remember, in every lesson when we factor, I'm going to start out with the tree map. So you can see that when we are factoring polynomials, we have different methods that we're going to use. Remember, our first method is there a GCF? Every single polynomial, that's what you have to ask yourself. Is there a GCF? Then we have to determine, can you keep factoring? So we're going to learn 4 methods on how to factor. We already know GCF. The first method we're going to learn is it a difference of squares? Okay, now, well, let's move on. Okay, so we're going to talk about this. Remember what a square is. A square means they have the same length and width, right? Same length and width. So in here, if I were to distribute x times x is x squared, x times negative 4 is negative 4x, 4 times x is 4x, and 4 times negative 4 is negative 16. These guys cancel out, so you are left with x squared minus 16. Okay? When you distribute this out, we get 25m squared minus 5m, double distribution, so I'm distributing the 1. And then 1 and negative 1 is negative 1. These guys cancel out, and I'm left with 25m squared minus 1. And this guy, we get 4a squared. 2a times negative 3b is negative 6ab. 3b times 2a is positive 6ab. And 3b times negative 3b is negative 9b squared. These guys cancel out, and I'm left with 4a squared minus 9b squared. Okay, what do all 3 of these guys have in common? These middle terms cancel out. If you look over here, it's almost a square. If you have a square, this side is x plus 4, and this side is x minus 4. So they have the same variable, and then they have opposite integers. So it's difference. Difference of squares means subtraction. Square means same side. So while they have the same variable and the same 4, one's positive and one's negative. So what here you're looking for is, does it fit the pattern? Is the pattern a difference of squares? Here's how you check. Do they have the same variable, and do they have opposite integers? They do. So it is a difference of square. And when you have a difference of square, this middle term will always cancel out, and it leaves you with x squared minus 16, 25m squared minus 1, 4a squared minus 3b squared. What do these guys all have in common? They're all negative, okay? So when you look at this, our goal for difference of squares is to go from a polynomial back into this form over here. That's what we're factoring. We need to get back to the factored form. So you have to ask yourself, does it fit the pattern of a difference of squares? And here's the questions you ask. Can you take a square root? Yes, you can. X and x give you x squared. Can you take the square root of 16? Yes, 4 and 4 gives you 16. And is it a negative? Yes. Then it is a difference of squares. If this were positive, you do not have a difference of squares. Okay? So let's go down here. First, you make sure you have an actual difference of squares. You must have a subtraction sign. That's what it means, difference. Difference means subtraction. Has to be a subtraction sign. If it's positive, it's prime. You cannot factor, okay? And you can square root both terms, just what we talked about. So look here. You can take the square root of a squared. You can take the square root of b squared, and that's negative. So here's what we do. It fits a pattern. You are going to take the square root of a, and you divide it, a and a. And you take the square root of b. So the first term in both of these is a. The second term in both of these is b. One's a negative b, one's a positive b. That's the factor work. That's the factor rule. And then you check at your work by doing the double distribution. So let's look at number 1. Now, remember, you always look for a GCF. These guys do not have a greatest common factor. So then I go, okay, is it a difference of square? It is, because I can take the square root of a, the square root of 4, and that's a subtraction sign. So remember, the first term in each of these is a. I split my a's. The second term in each of these is 2, because square root of 4 is 2. One's negative and one's positive. Does it matter if you put the positive and the negative? No, because when you check your answer, you're going to get that right answer. So remember, this is a square, so a minus 2, it's a difference of square. So I get a squared, negative 2a, positive 2a, negative 4. Those guys cancel out. A squared minus 4 is what you're left with. That middle term will always cancel out. Okay. Do not change the order here. Usually we look at variables first. Don't change the order. It fits the pattern. Is there a GCF? No. But does it fit the pattern, a square root and a square root and a subtraction sign? Yes. So I break it up into 2 parts. The first part, the first term in each of these is 9. Square root of 81 is 9 and 9. The second piece, the square root of x squared, is x and x. One is positive, one is negative. And then when you check it, 9 plus x, 9 minus x, I get 81, 9x, negative 9x, negative x squared. Those guys cancel out, 81 minus x squared, so that is correct. Look at number 5. There's no GCF. Does it fit the pattern of a difference of squares? Can you take the square root of k squared? Yes. Can you take the square root of 25? Yes. Is that a negative? No. It is prime. There is not 2 numbers that are going to multiply together to cancel out that middle term. When you cancel out this middle term, one has to be positive and one has to be negative. That's where they get those opposites. If these were both negative, you know, if you had k plus 5 and k plus 5, when you checked your answer, you would see that that's 10k. Okay, and then maybe you think, oh, well, what if these were both negative? Well, then you would get a negative 5k and a negative 5k, and that would give you negative 10k, which then creates a trinomial. So you cannot have this be positive and have a difference of squares. It has to be negative, okay? All right, number 7. Can you take a GCF? There is no GCF. So, does it fit the form of a difference of squares? Can you take the square root of 9b squared? Yes. Can you take the square root of 100? Yes. Is it negative? Yes. So when you take the square root, 3b, so 3b is going to go in the first position, and then the second position, 10 and 10, one's negative, one's positive. That's a difference of square. Look over here at number 8. No GCF. It does fit the form, so I'm going to do a 5x, 5x, a 7 and a 7, one's negative and one's positive, and of course you can check your answer on these. Okay, let's look at number 11. Does it fit the form? Yes, yes, and it's negative. What is the square root of 4h squared? 2h, so that's going to go in the first section. 5g, that's the second section. One's negative, one's positive. Okay, let's take a look at the next page. All right, I think you got the hint there. Let's do 13 real quick. Does it fit the form of a difference of squares? Yes, they're evenly separated, and the square root of 1 is 1. So the square root of x squared y is xy, so that goes in the first term. Square root of 1 is 1. That's the second term. One's negative and one's positive. Okay. Now, down here, remember at the beginning of this, I said you always have to make sure you take your GCF, right? So this is what I mean. Do they have a GCF? Yeah, like right now, it doesn't fit the form of a difference of squares. So I can't do difference of squares. So I look for a GCF. My GCF is 2, so I'm going to take it out. And then what's left over? N squared minus 36. Okay. Listen to this part of the video. If I asked you to do a factor tree of 24, a prime factorization tree, and I said 2 and 12, 2 and 6, and you told me 2 times 2 times 6 is the answer, you would be wrong. You'd be wrong. You'd get it wrong. Because 6 is not prime. You have to keep factoring. It's the same thing over here. So think about it. You branched it. You took your GCF out too, but can you keep going? Yes, we have a difference of square. So if you have a difference of square, we factor it out. It fits the form, square root, that's negative. So square root of n squared is n and n. And then the second term is 6. One negative and one is positive. Do not forget to bring your GCF down. This is my whole answer, okay? If I just check this part, n plus 6 and n minus 6, I get n squared minus 36. That doesn't give me my original, because you then have to multiply by the GCF to get n squared minus 72. So when you check your answer, you got to multiply all of these together, okay? All right, let's look at number 23. Is there a GCF? What do they have in common? The 4, a 2. They have a 2 in common. They don't have any variables. So I'm going to take a 2 out, and you have 16 s squared minus 9 u squared. Okay, I factored that out. There is no more GCF, but is this a difference of square? Can I take the square root of the first term? Yes. Can I take the square root of the second term? Yes. Is this a negative? Yes. So I factor 4s and 4s go in the first term. 3u and 3u go in the second term. One's negative, one's positive. Do not forget to bring down your GCF. You took a 2 out, now you bring it back. These are all factors. They are all relatively prime. Okay? All right, let's look at number 25. Do they have a GCF? Yes, they do. What would your GCF be? 8, 9, 3. So let's take a 3 out. So I get 8a squared minus 118 b squared. So they still have an 8 and 18. They still have a 2 in common. So I didn't take the GCF out. I need to take a 2 out. And when you take a 2 out, you have 4a squared minus 9b squared. And then 2 times 3 is 6. So I should have started that my GCF was 6. I didn't recognize it. I didn't. That's why you ask yourself, is it relatively prime? So now, are you done when you take 6 out? Well, can you take the square root? Yes. Can you take the square root? Yes. And it's negative. So it fits the form. So I square root 2a and 2a, 3b and 3b. One's negative, one's positive. Do not forget to bring down your GCF. Is 6. Okay? All right. Let's take a look at number 7. They both have a 5 in common, and they both have 2 n's in common. Remember, don't forget to take out your monomial, your variable. So you've got a 116 n squared minus 25. You took 2 n's out, and that's what's left. I asked myself, is it relatively prime? Yep, they have nothing else in common. But is it a difference of square? I can take the square root. I can take the square root, and that's negative. So the square root of 16n is 4n. That goes in the first term. And 5 and 5. One's negative, one's positive. Do not forget to bring down your GCF. And that's my final answer. Okay? Look at number 29. I take out my GCF. My GCF is 9p. And I have a 4p squared minus 1. Anything divided by itself is 1. They have nothing else in common. But can I do a difference of square? Does it fit the pattern? Square root, yes. Square root, yes. Is it negative? Yes. So I'm going to factor by difference of square. One's negative, one's positive. Do not forget to bring down your GCF. So that is my final answer. Okay? So we're going to practice this, but if you're struggling, come and see me.